In our previous lecture, we got an overview on what bubble sort is and how it works. So now that we have a good understanding of how bubble sort works, we can begin implementing our own solution for that algorithm. So the first thing I want to do is create a new function called bubble sort, and it's going to look very similar to what we did for selection sort. So we're going to create a bubble sort function, and we're going to pass in a mutable reference to a vector that's also going to return a vector. And then down here I want to go ahead and create some of our test cases. So we will say let mut vec equals vec, and then in here I want to mimic our test cases that we did in the previous lecture. So we did a 5, 4, 1, 1, 1, 3, 2. And then we also did a 5, 1, 4, 2, and 8. So now in here we know that we are going to run bubble sort, and we're going to pass in a mutable reference to our vec, and then we know that we're going to want to print it out to make sure that our vector was properly sorted. And we'll stop there for now. That way we can make sure that this at least works before we continue down here. So now up here in the function, we're going to start implementing in our algorithm. So we know that we're going to need two for loops. So we'll go ahead and create our first for loop, and we'll say for I in 1, 2, the array dot length -1. And since we know from the previous lecture that we actually don't use this I variable, we can substitute it with the underscore, and basically this tells our compiler, hey, we don't care about this value, so just put a placeholder in there and we're not going to reference that value at all. But in our next for loop, we do know that we're going to reference j, and j is going to go from 0 to array length -2, and then here is where we are going to do our check. So we're going to say if array of j is greater than array of j plus 1, well, now we want to do our swap. So we will say array swap, and we have j and j plus 1. And at the very end we want to return our array, and then we will get an error mismatch down here because it says it expected a struct of vec I8, and we found a mutable reference, so we can quickly rectify that by saying to vec, and now our error is gone. So now if we come back down here and we execute our code, we would expect to see the first vector of 5, 4, 1, 3, 2 print out a sorted vector, which we see down here. We see that we have 1, 2, 3, 4, and 5. So our bubble sort is working correctly, but to verify, let's run it on our second test case of our vec2, and let's do the same thing where we just go ahead and print that out. And if we run this again, we see we have 1, 2, 4, 5, 8 printed out, which is sorted of the vector containing 5, 1, 4, 2, 8. So awesome. So it looks like our bubble sort algorithm is indeed working correctly. But if you remember from the previous lecture, there are times where our algorithm can be sorted, or excuse me, our vector can be sorted, but we're still executing these blocks of code. Therefore, we're wasting resources and time. because we could still be executing at this loop even though we know that we're sorted in here. So we can actually do a very slight little optimization here, and we can create a mutable boolean called sorted, and we'll go ahead and set it to true. But we'll also, at each new iteration of the loop, we'll make sure that it is set to true, because we know that if this block of code gets executed, then we are not sorted. So that means we want it to keep sorting out. But if this block of code never gets executed, then that means we are sorted. And since we have this boolean here and it won't get updated in here, because if it's sorted, this block of code never gets updated, then we can put an if statement down here that says, hey, if we're sorted, then I want you to break out of this loop, meaning this outer loop. And so if sorted here, this basically says if sorted is true, then break out. So with that little bit of optimization, just to make sure our code still functions as desired, 1, 2, 3, 4, 5, and 1, 2, 4, 5, and 8, those are the correct outputs. So this is an optimization that would be better for a much larger array that does sort itself, let's say halfway through. Well, we just cut the O of n squared in half. So obviously, with certain sizes of arrays, this would be a considerable performance increase. But that was just something I wanted to point out, just to kind of keep in the back of your mind as we go through these algorithms. I want you to try to think of ways that maybe you can optimize them. And if you do have unique solutions to optimize some of these arrays, because there's definitely optimizations to be made, please share them with with me and the rest of the students in the course. But hopefully you enjoyed learning about bubble sort, and we will continue looking at a few more algorithms in the next lecture.